Lesson 9.1 Multiple Representations of Functions. Essential question, please write it down. How do I translate between the various representations of functions? Who uses this? An amusement park manager can use representations of functions such as graphs and tables to analyze ticket sales. So, we're going to talk about different ways to represent data. We can use tables, we can use graphs, we can use equations, and we can use verbal descriptions. Example 1. It says sketch a possible graph to represent the following. Ticket sales were good until a massive power outage happened on Saturday that was not repaired until late Sunday. So when we look at this graph, you can see sales are really high on Friday. They drop drastically on Saturday due to the power outage. They continue to drop on Sunday. They're repaired on Sunday. So Monday, the ticket sales start to go up. So we have to be careful and read the words and then sketch a graph based on the words or vice versa. And sketching the graph here was already done for us. Example 2. The weather was beautiful on Friday and Saturday, but it rained all day on Sunday and Monday. So again, we're talking about possible sales and days of the week. So beautiful on Friday, sales are going to be really high. And Saturday, obviously sales are going to go up even more because it's a weekend. But then it rained all day Sunday. Sales dropped drastically on Sunday and stayed low again on Monday. So this lesson you're going to find out is a lot of common sense. Example 3. Sketch a possible graph to represent the following. Only half of the rides were running on Friday and Sunday. Again, sales. As you can see, sales are low on Friday, low on Sunday, because only half of the rides were running. Sales were high on Saturday and higher on Monday, but Saturday obviously was the highest because it's a weekend. All right, example 4. A manager at an amusement park monitors the ticket sales at the park over a 4-day weekend. Match each situation to one of the following graphs. Sketch a possible graph of the situation if the situation does not match any of the given graphs. So, A, the park was closed on Friday for repairs. Well, obviously it gives us the answer here. So if the park was closed on Friday, obviously sales are going to be at 0. So obviously graph 1 and 3 we would not pick. So that's an obvious situation there. B, the park hosted a big concert on Saturday and a parade on Monday. So obviously we're going to pick graph 3. Big concert on Saturday, sales are up, and a parade on Monday, so sales are up again on Monday. And C, the park was very busy during the holiday weekend. And as we can see, holiday weekend, sales are up. So it's a lot of reading and interpreting and a lot of common sense in this lesson. Example 5. An amusement park manager estimates daily profits by multiplying the number of tickets sold by 20. This verbal description is useful, but other representations of the function may be more useful. All right. So we're given the equation, we're given the table, and we're given the graph. So let's take a closer look at this. If P is equal to profit and N is number of tickets sold. So N, here's our tickets sold. Obviously, as our tickets sold goes up, our profit's going to go up, and it's a linear situation. And basically how we come up with our equation, if it wasn't given to us, is we'd have to use the words. An amusement park manager estimates daily profits by multiplying the number of tickets sold by 20. That's where we get 20 times N. Example 6. Kurt is rappelling down a 500-foot cliff at a rate of 6 feet per second. We're going to create a table, which is already created for us. an equation and a graph to represent Kurt's height from the ground with relation to time. When will Kurt reach the ground? All right. So as we can see, we start at 500 feet, and each second, Kurt is repelling at a rate of 6 feet per second. So thus, we're going down by 6 each time our time goes up. He repels at 6 feet per second. This is here. Let's erase that. All right. So we're going to write an equation right now. And the equation is going to use the height. So our height is equal to, we start at 500 and we're minusing 6 feet per second. Okay. So we have to find the intercepts and graph. Well, first of all, we're going to find the H intercept. And how do we do that? We set t equal to 0. Well, obviously, when t equals 0, this is kind of common sense here. Whoops, that's 0. The height is 500, our starting point. Yeah, we already knew that. So our first intercept is obviously 0, 500. When will Kurt reach the ground? Well, what we have to do there is h is the height. H is Kurt's height in feet from the ground. Kurt begins at a height of 500 feet and the height decreases by 6 feet each second. So if we want to find the other intercept, which is finding when will Kurt reach the ground, let's highlight that. We have to set h equal to 0. So we're going to set h equal to 0 in that equation. So remember our equation right here is h is equal to 500 minus 6t. So if we set h equal to 0, that's going to tell us how long will it take for Kurt to hit the ground. So we're going to minus 500. And we're going to divide by negative 6. 83.3. Repeating. And we're dealing with seconds. So basically, as an ordered pair, if we have time is our x value and h is our y value, there's our ordered pair. And when it asks, when will Kurt reach the ground? Kurt reaches the ground after 83.3 repeating seconds. And if we do a quick sketch of the graph of that, so 20, 40. This is time. And height. And obviously, we're going to start at, we're going to erase this a little bit here. We're going to start at 500 feet, and we're going down because we're rappelling down. And when we rappel down, eventually we're going to reach right there. When t is equal to 0, the height is at 83.3. Or when we reach the ground, the height is 0. How long does it take to reach the ground? 83.3 seconds. So on a lot of these problems, we're going to find both the x-intercept and the y-intercept to finish solving the problem. Example 7 and 8 we're going to do in class, and here is here's the video questions.